G'day guys. This is a follow-up to the last video that I did on op-amp offset in the GPX4500 detector. So we're back to the same configuration. I have the figure 8 cancel coil connected, and what I've done to fix this offset issue, I have to turn the detector around a little bit, zoom in a bit, around there and down there. I've added a 20,000 ohm trim pot, which is a 3-legged device, and it's just a adjustable resistor. And with these resistors, they have two connections, which is across the whole resistance, which is a fixed resistance of 20,000 ohms, and the middle leg here is adjustable with this top screw, as not the leg but the resistance between that leg and each end of the trim pot on the other two connections. So it's a sliding scale of resistance. You know, if you do it one way towards say the end, you'll get down to 19,000 ohms, and the other end from the center wiper will measure 1,000 to make a total of 20. And if you adjust it directly in the middle, you'll have 10,000 ohms to one leg and 10,000 ohms to the other leg. So you can slide it up and down. It changes the resistance between the two legs, just depending where you adjust it. So on this one, we have got one end, the non-adjustable part of the resistor, on pin 5 of the AD797. We have the other end, the non-adjustable part of the resistor, on pin 1 of the AD797. And the adjustable leg goes to pin 4, which is negative voltage supply to the op-amp. Now, I'll just turn this on, turn the detector on. And I've got it, like I say, I've got it in cancel mode on a cancel coil. It'll be completely dead quiet. So what we'll do now, we'll have a look at the oscilloscope, which is over there. It probably looks like it's flickering and carrying on because of the scan rate of the camera, but it's a stable trace. It just looks that way. So if we go to the, I measured both of these op amps. I actually shorted pin 2 to pin 3 on each op amp, and when you do that, do not have the coil connected. The reason being is that the flyback voltage has to go through 2 MOSFETs, and by loading it like that, it could cause too much current through the MOSFETs on the remainder of the flyback, and it could burn the MOSFETs out. So if you're going to do that, shorting out the pins, take the coil off. If you're just going to look at the one with the least offset in situation, then you can just leave that one alone. So this is the one that had the least offset. Okay, if I can actually get onto it. There we go. Now, as you can see on that waveform there, it's got it set at 20 millivolts in 50 microseconds. And I've got my cursors in the horizontal mode, and I've got it lined up with the top of the waveform and the drop-offs on the bottom of the waveform. So you can see it there. Now, on the other op amp, the one I've got the resistor on, or the variable resistor, I'll just hook him up. Okay, that is an example of offset. So it is higher than the other one. There's no way, no signals or match going through the 4053. So I'm just adjusting the resistor now. We might have some, typical, isn't it? Oh, it's level. There we go, get on there. Okay, sometimes these oscilloscopes, when you have a lot of different shape waveforms, they go out of lock, but that's pretty normal, even on a high-end oscilloscope. So what we do, we adjust this one here, and we get those levels the same as what the other op amp was. You've got to remember both input channels have to be identical on the same load, same coil, and basically a mono. You can't do this on a double D because you've got different impedances in the different windings, and it'll be all skewy. So that is how this works. Now, this is combining the mono coil, if you're going to use monos, very accurately into the detector. There's probably still a few little tiny issues we need to look at around the scaling resistors around the multiplexer, but we can do that. I think they're 2.2K or 1.5K. You just put a pot across, take them out, put a pot across one, and you adjust it by the same process again. And I'll just show you something here. If I go around here, now I'm on the wrong side of the camera. I'm sort of working behind it, but we'll go down. Okay. Now, I've got this great whopping lump of metal. And what you can actually do is adjust the input and minimize the target response on something like this, because as we're using the detector in cancel mode, even with a mono coil on it, any signal going through via the cancel mode, the way it's set up, how it switches through the multiplexer, will change one output of the op amp, one op amp. It'll flip it 180 degrees and it should cancel. But there's always a little bit of extra trimming to be done down the circuit. So I mean, if I stick it right in the middle of the coil, it's going to scream. But you can see that it's very minimal, the effect of such a big piece of metal on the coil. This is how you know it's working properly. Oh, if you want to actually see what effect it has on the oscilloscope with a big piece of metal, so, you know, use this thing again. This is what you're getting. Now, if that was in straight mono mode or something like that, it would absolutely scream. But you know, that's a massive change in waveform there, and normally that would scream like a banshee. So if I got this and I said, okay, we're going to put the detector in mono mode, which I've just done, even with the cancel coil, you know, I get that metal, you know, I'm way out from the coil. See, you don't get much movement. We're looking at 20 millivolts, and you know, we're probably moving at a few nanovolts, and the detector sounds off. That's how sensitive these things are. And if I go really close to the coil, so I'll stick that back into cancel mode, and the detector is nice and quiet. What we can do too, because we're getting better signal recovery with the detector switched into double D mode with a mono type coil on it, let's have a look at the sensitivity now that I've taken the offset out of the front end. So what we'll do, I'm going to put it into double D mode, so we're just using 1 op amp. You can hear the noise come through. I'm going to use 0.05 on the coil. You're probably just going to hear this. I'm just tapping the coil, trying to get the same swing. I'm not in the middle of the coil. I can't get that. Oh, I'll turn this around so you can see. Now, where am I? Okay, I'm just tapping near the top of the coil with a 0.05. Okay, it's hardly picking it up. Let's go into mono and see if there's any improvement. There's an improvement. So the input offset does lower the sensitivity of the detector. We've got both op amps working at the moment and they're matched. So just that adjustment has increased the sensitivity than what we found in the past by having increased sensitivity on a mono whilst having tongue-tied, having the detector switched into double D. I'd say there's double signal response or very close to it. And let's go back into double D mode. Less signal. Okay, so all you people out there who have the detector, I'll just switch this back into cancel. So all you people out there who have these detectors work better in double D with a mono, you can do this little modification or get your friendly electronic technician who's competent in the trade to do this for you, and you can then perfectly equalize the outputs of the op amps to combine correctly, and you will get pretty close to a 3 decibel improvement in signal response, signal to noise ratio. Obviously, it just works better. I just proved the point. So it's definitely worthwhile for anyone out there for GPX detector. It would even work with a GP because you've got the 2 op amps on them. Just be careful on the GPs too. A lot of them had NE5534s inserted in this position here, and very carefully flip them out and put some AD797s in there. They are a far better op amp. We're talking with the NE5534s, which is some detectors have it, some detectors don't. And the way to find out is once you take the chips off, if they've got a smooth, flat bottom, they will be an AD797. And if they have a little circle in the middle with a date code and whatever else stuck in the middle, it more than likely will be an NE5534. So the 5534s have a noise figure of 3.5 dB at their corner frequency, and the AD797 has a noise figure of 0.9. For memory, I'll just say it's 1 rather than 0.9, close enough. So much better when you combine 2 AD797s. That 3 decibel reduction in noise will bring it down to about 0.7 or so, maybe a tad lower, a tad higher. We're getting into theoretical lower limits for this type of equipment with those noise figures. there is noise generated by the input FETs. The resistance of the input FETs contribute to the noise. So that's why in a lot of the updates I do to these detectors, I swap out the input devices for my special N channels. The ones I've got have far less capacitance, and they only have around about 1.1 ohms of resistance when saturated or turned on fully. And the other ones I've got also have about half the capacitance of the existing devices in these, and also less resistance. So lowering the resistance through the switching network to the op amps will also reduce the noise floor, and because you're not losing signal in the noise, you'll get better signal recovery. So as technology improves over time from when these were made, we can upgrade these detectors to be far better than what they were. So, my my own 4500 I use absolutely, is a nugget finder extraordinaire detector. It really is really good. It absolutely leaves standard detectors for dead in, detecting very, very tiny gold, or getting more of a signal on deeper gold. It's proven many times over many videos. It works really, really well. And yeah, that's the little trick that can be done now, trimming the offset on the op amps to make mono mode work as it should be if there is an offset between those two op amps. And I really recommend, if you do have, you can't tell what devices are in here at the moment. If I get my pen with the plastic, like that one there and that one there, just looking at it, you can't tell what they are. And if you really wanted to measure these devices in circuit, it'd be very hard. You would need very specialized noise figure measuring equipment, and yeah, I don't even think you'd be able to do it because of the componentry all connected on the input. You'd have to remove the devices, right? And like I say, be careful removing the devices. If you don't heat the whole thing up, and all these legs are basically unsoldered or unsoldered, it will pull the tracks off, and there's little through plates and that around these devices, and if you don't know where they go on the other side of the board, you will make a complete mess of your detector. If you don't know what you're doing and you're not competent, don't try it. Get someone who knows what they're doing with the proper equipment. Um, and you got to be careful. You just can't go, oh, yeah, I'll just go and rip those out and put new ones in. No, 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 no. Don't do that. You'll end up with a complete disaster. But there's an improvement for you. And this has been a bugbear of many a detectorist, so they tell me. I've had a lot of people tell me. They said, oh, yeah, we always use it in double D mode because it works better. And that's just ridiculous. It should work better in mono because of the dual op amp situation. But anyway, matching those has made a really good improvement. But also, you can probably do a little bit more around the 4053. And, do we need to? Yeah, if you really want to. I might investigate that and do another video on it and just see how far and how good we can get this thing cancelling out, you know, even big, large metal objects. And also the other thing too, running these matched will improve your ground balance because there's less offset signal coming through as well. Everything is matched, and it's going to work far better. You can look at it like a twin engine jet, right? And if you have one engine putting out 5%, greater power than the other, the plane is going to need the rear stable or the tail rudder offset to compensate. It's the same sort of thing. You know, you don't want compensation like that. You want everything balanced. So you know you can have your rudder straight, and the plane will go perfectly straight and use less fuel. Because if you're going to do a trim like that, it's going to cause drag, and you're going to burn extra fuel. The same principle applies. I'm just making it easy speak, so you know anyone will understand that. You know the same initial signal is being reproduced perfectly by both op amps and then recombined. So there you go. That's the update on this. And like I say, if you didn't catch where to put the trim pot, you could use a 10K. 20K is recommended by Analog Devices. I have read the spec sheet, and it is the wiper goes to negative supply, which is pin 4. One end goes to pin 1, the other end goes to pin 5. There's nothing else you need to do to the circuit. Just get the roughly before when you put it in, put the wiper in the middle, so you got 10K each side of the middle wiper. You don't want it jammed up one end or the other. I don't know what would happen. I've never done that, but you only need to trim it very slightly. It's only, you know, maybe out of the whole range, it could be moving at 500 ohms or something from center. So, you know, the devices are pretty good, but you know, if you do have an offset problem, it's easy to test. Mono coil, measure the outputs on an oscilloscope of the waveform, like so. Put some cursors up, and just go from pin 6 on the output of one op amp, and then go and look at pin 6 on the other. And if they're not the same, well, then you've got a problem. So, you know, if they're slightly out, it's probably not going to do much. But this was really quite far out for what it was doing, and just by, like in the previous video, I actually showed that it was working better in um, the double D mode on the detector and with a test target. And when I put in mono, the signal went down. But then when these are aligned up perfectly in mono now, the signal is up. So that's not a problem. You know that we do detector upgrades, and we put new front ends in, and we do all sorts of things. We put variable frequency and all the rest in these detectors. We put new components in there. We make these work a lot better than they did. So if you want your detector done, we can do it. Just go on detectormods.com is our website, and yeah, you can contact us through the email contact or the phone number on detectormods.com, and it'll keep Dave busy. Yeah, so that's that. I hope all you detectorists have learnt something about the electronics in these detectors. You know, there is a lot that can be done for improvements. There's even you know, all these op amps along here. Whoops, I'll put the camera down so you can see what I'm pointing at. Where are we? There we go. All these op amps here. There's new ones out now that can be fitted, and you'll get there's less overall noise generated in these devices. There's a lot of things that can be changed. Even down here, if we look even at the output stages, these can be changed to different devices now. These diodes can be changed to different devices which have less loss and less capacitance, which is important. All these components in here, the N-channel MOSFETs there, and where are you? Forget where they are half the time. One's there, one's there. There you go. Don't confuse them with the BAV99 protection diodes. they can be changed to new devices. The underside, we got those special devices we had made for us. We can change those out as well. The whatever they are, 2SK1334s. You can flick them out of circuit and put new ones in. Yeah, there's a lot of things that can be done. We've increased the capacitors. We've increased the values of these. But do you really need to do it? Depends. These things lose value over time, and some of them are only rated to like 2,000 hours, and they'll be down pretty close to about 80% drop of capacity. So it depends how long you use your detector for. That all these capacitors degrade. The one that degrades the most in most cases is this 200 volt thing here. Because it's getting whacked with, it's got 200 volts on it. It does get a bit warm sometimes and dries out the, it's warm. It dries out the electrolyte. It does slightly gas off. There's probably other chemical reactions inside the capacitors too, which degrade them. And so it's very hard because it's very difficult to measure a capacitor like this whilst it's in circuit. There is ways of doing it, but all the other componentry loads onto it, and you'll get a false reading in most cases. So you really have to undo them and pull them out. And this being multi-layer board, don't do it if you haven't got the right equipment to do it. You'll wreck your detector. I stress this, that pulling a capacitor out, you say, oh, I'll put new capacitors in, right? You don't heat the legs up properly. You have where it's been trimmed off on the bottom. It's got a bit of metal sticking out off the leg sideways. It can rip the through plates out, and you will have a stuffed detector. Leave it to professionals that do this stuff, and then there'll be no tears. So done properly, it's worthwhile doing these upgrades. But um, you know, simple things like this resistor thing, you can do it yourself, but you just make sure you know what you're doing. Don't short the legs together and put blobs of solder all over it and hook up the wrong legs and doing all sorts of silly things like that, because it'll only bring tears. So really, you should get someone really competent to do it. Anyway, that's enough of that. Um, this is working really, really well, and it's running really nicely. It's very, very quiet because it's on cancelling on a cancel coil. So yeah, I like the quiet detectors, but not this quiet. Won't pick up anything. But you flick it back out of cancel, stick it in the mono, and even so, in the room, it's very, very quiet. So I think it's actually um, done an improvement on the EMI response, because normally in mono, even on a cancel coil in here, there's a lot more EMI than that. So oh Jesus, yeah, okay, it's as sensitive as almighty, Yeah, I just hit it with a 0.1, 0.1. So yeah, nothing wrong with that. A good overall improvement, I would say. And yeah, can't keep going on about it. It is what it is. And the only other thing to do is probably play around the 4053 multiplexer, just to make sure that the losses, all these ICs have losses, and because it's using that as a switch to control, the cancel, double D, and mono modes. Any imbalances around those resistors that do the offset, that could cause an imbalance, and imbalances may affect ground balance, signal recovery, noise, everything. So we'll look at that at a later date and see how we go. But this is a repair detector for a customer, by the way, and basically a lot of the problem was that offset, as we've discovered, and it also had other problems too. I think it went bonkers for some reason. If I got the right detector, I got a few detectors in, so I'll see. Yeah, repair, then quote upgrades. Okay, well, it's repaired. It's had the offset fixed. So push. What's it say? Push something. Push mod something's. Oh yeah. Okay, I think it's code for what upgrades are needed. But anyway, that's just the case of the detector going near the coil. Okay, good enough. This is fixed, and yeah, we'll have to talk and see if he wants the rest of the upgrades put in. That means that if I put the upgrades in, I'm going to have to put a miniaturized potentiometer in here. Or the other way of doing it, I can measure between the legs of the potentiometer, and if it comes up very close to fixed resistor values, I can just put two little surface mount resistors in there. But you know, it might be a strange value, and I might not be able to do that. But yeah, I've got some miniature flat pots as well, so or trimmers. We'll call them trimmers, trim pots, and yeah, really tiny ones. They're really hard to work with, but I can do it. And yeah, she's a goer. Anyway, catch us later.